All right, let's do some examples of the shell method here. So let's start off with this one. We're going to have the curve y equals x minus x cubed on the interval from 0 to 1. And we're going to go about the y-axis. So this is our first example where you'll see pretty quick that we can't do the problem in terms of y. And despite it being, despite knowing pretty well the washer and disk method. So let me show you what this area looks like. So we got y-axis here, around the y-axis, and then the x-axis on here. We're starting at 0. It looks something like this on the interval from 0 to 1. Here's 1. And then we are going to, like I said, we're rotating around the y-axis. So this function is in terms of x, right? It's y equals x minus x cubed. And so if you draw in the representative rectangle, or you draw in the rectangle here, you can see that it's parallel to the axis of revolution. And sometimes if you're trying to figure out whether you should be in x and y, x or y, you should think, what is the, if I was trying to find the area, which form, x or y, would be easiest to find the area. So if I was trying to find this area, the easiest way to do it would be to integrate from 0 to 1 of x minus x cubed. So if that's the case, then when you rotate it, it's probably going to be easiest to keep it in terms of x as well. Also, with this problem, we can't turn it into, we can't make it in terms of y. So like if we were trying to use the disk method or the washer method, we would have to be in terms of y. We can't get it in terms of y. We can't isolate x. So we're stuck with this. And that implies that we need to use the shell method. So to figure out the volume using the shell method, we need to identify both p of x and h of x. All right, so p of x is this distance here, and in this example, that distance is just whatever x is. Okay, so we have p of x is equal to x. Okay, so I mean, think about it like this. So if the rectangle was drawn at 0.75, then x would be 0.75. The distance would be 0.75. If it was at 0.2, x would be 0.2. That would be the distance. Right? So p of x is equal to x. The height, h of x, is going to be equal to whatever the function height is. So it's x minus x cubed. And then we're in terms of x. The rectangle is vertical, therefore dx is going to be the thickness of that rectangle. Okay, so now we can figure out what the volume is. The volume is going to be equal to 2 pi, the integral from 0 to 1, we're looking at the x-axis here, 0 to 1 of p of x, which is x, times x minus x cubed, which is h of x, all with respect to x. You end up with 4 pi over 15 when you do that. Okay, let's do another one. You might try this one on your own, pause the video, and then see how it goes. So this equation, we're going to write x equals e to the negative y squared on the interval from 0 to 1 along the y, along the y's, and then it's going to go about the x-axis. All right, and so if we do that, then this is the setup here. So we will draw on the y-axis, draw on the x-axis here, and on this interval, the graph looks something like this-ish. And we're only going from 0 to 1 on the y-axis, so that goes from 0 to 1. And then what you can see is that your equation is given in terms of y. And then, so to find the area, the easiest thing to do would be to go from 0 to 1 on the y-axis. You can draw on your little rectangle here, your representative rectangle. You could see that since it's horizontal, the thickness of it is dy. Right? And so leaving everything, and again, we're going around the x-axis. Leaving everything in terms of y is going to be the easiest way to find the area. It's also going to be the easiest way to find the volume. So using the shell method, all we need to know is the distance from, what defines the distance from the rectangle to the axis of revolution. In this case, p of y will be y. Again, if y is something like 0.7, then, I'm sorry, if the rectangle is at 0.7, that is whatever the y value is. We will do one that isn't around an axis, and you'll see the difference, and you'll see when p of y can change to something other than just y, or when p of x is something other than just x. Okay, so we've got P, then we just need to figure out what H is. H is, again, the height of the rectangle, so what defines that? If you look here, wherever you draw the rectangle, the height is defined as the distance from the axis to the curve. That curve is e to the negative y squared, so this is e to the negative y squared. So we can set up our formula for volume. It's going to be 2 pi from 0 to 1 along the y-axis. P of y, which is y, times e to the negative y squared dy. And when you compute that, it's got e in it, so the volume doesn't come out to be a nice number. You end up with 1.986. So last problem we'll do is we should do one where it's around an axis of revolution that is not the x or the y-axis. So let's take this simple function, y equals square root of x, from 0 to 4. And we're going to go about x equals negative 2. All right? So y equals square root of x. Let's see here. Y equals square root of x is something like this. Let's say that this is 4 right here. Okay, so we want to take this region and we want to spin it around x equals negative 2. So let's put negative 2 right here. So this will be our axis of revolution. All right, and so to do this, let's use the shell method, although you could use the disk or the washer method on this. You could use the washer method, but let's stick with the shell method so we can see how we would handle it here. So we've got to be in terms of x because the thickness is in terms of x. Notice that the rectangle is parallel to the axis of revolution. So we want to know what p of x is. That's the distance from the rectangle to the axis of revolution. And that distance is going to be, it's going to be 2 parts. Okay, so this piece right here is always 2. All right, and then this piece here is going to be x, whatever the x value is. So p of x will be equal to x plus 2. Then we need to figure out what the height is. So the height is going to be defined by whatever the function height is. So h of x is going to be square root of x. So our formula for volume then is 2 pi. We're going along the x-axis for our bounds, so from 0 to 4. And then we're going to go p of x, which is x plus 2, times square root of x, all with respect to x. Right? And I didn't write down the answer for that, but the setup is the most important piece. Okay, so moving the axis of revolution around will just change the p of x. And we'll do several problems like that where we're playing around with where the axis of revolution is so you can get sort of comfortable with how that changes. But I can't emphasize enough how important it is to draw in that rectangle, use that as kind of your foundation for identifying all of your pieces, and then in relation to the axis of revolution. And that makes the problems a lot easier rather than just kind of staring at the area and trying to get at it in that way. And I think that pretty much wraps up the shell method.